Welcome to the channel and welcome back if you've been here in a previous episode. For today's video, we will be looking at the UPS function test for the LV6548 MPP all-in-one solar inverter. So here are the loads that we have. We have a desktop computer, desktop monitor, and a laptop which I have taken the battery out. I will put a load on both systems just to make sure that the systems are not idling and just to verify that they are able to switch over to battery and bypass mode without any problems. Let's check the program option for UPS. It's currently enabled. The other option is appliance mode. We're going to pick UPS. We'll select that. So right now let's start a load test on desktop system and let's play the 4K video for the laptop. Alright, the loads are currently running. I'm going to turn the AC input back on and we'll see if we have any problems going back to bypass mode. There was a little bit of flicker in the LED lights. I haven't mentioned it, but I do have an additional 4 LED lights that are also on the same circuit as the two computers over here. So going back to battery mode again, turning off AC input. I don't know how well that would show on video, but I did get a quick flicker with the LED lights that are on the inverter circuit. So we'll try it a few more times. Okay, so it looks like the UPS function works fine. There's no problems switching between bypass mode and battery mode with the... I should also try to add a few other additional loads on the same circuit as these two computers. So let's add a space heater. We're going to add this 1500 watt space heater and a 1000 watt toaster oven convection oven load. That will give us a additional 2500 watts on top of these two computers. It should switch over just fine, but I do want to test it to be completely sure. We are currently in bypass mode. We are going to switch over to battery and see if the system, see if UPS mode will still function. I saw a flicker. I did see a much slower flicker where the duration of the flicker on the LED lights, that flicker was much longer with these 2500 watts of additional load versus just having the two computers. We're currently in battery. Check amps on the battery side. 56 amps from the battery side. Most of it being the space heater loads. Let's go back to bypass mode. No problem switching over. A little bit of a flicker. Let's try that a few more times. Okay, going back to battery mode. And going back to battery. Okay, something I want to show really quick is the waveform on the scope when switching between bypass and battery mode. Okay, this is currently in bypass mode, so this is grid power waveform, and we're going to go to battery. You see it's much smoother, of course. This is all still in UPS mode. Back to UPS. What's interesting, I'm noticing there's a slight ripple over here the moment I switch over to battery mode. There was a bit of a ripple. I'm sorry, my mistake. This is switching back to bypass mode before it goes back to grid power. When you switch back on the AC input, going back to battery mode, going back to bypass mode, there was a bit of a ripple on this part of the waveform, just right here. So let's turn off, let's go back to bypass. Right there, that's the ripple that I'm talking about. It's just there for a brief moment until loads are reconnected back over to grid. And that's when, of course, the rippling stops. Next thing we will try is, let's go to appliance mode in the inverter. Okay, you can see that's UPS means that's the function we're currently using. We're going to switch to appliance. Alright, so we're back in appliance mode, and we'll first try this without the two space heater and convection oven loads. So it's going to be, so we currently still have the LED lights on and the desktop computer and the laptop, of course. This is the appliance mode switchover. We're currently in battery. Let's switch back to appliance and see if that desktop system will stay on. Okay, looks like it stayed on. No power interruptions. This is the interesting one. We're going to go back to battery mode now, switching off AC input in appliance mode. Nope. Nope. It cannot do it. I was wrong there. It restarted this monitor. Okay. If you saw it flicker purple and the BenQ logo, that's the monitor restarting. Since we still have a load running on the system, let's try it again. Going back to bypass mode. Going back to battery mode. Aha! So, that's an interesting result. It restarts the desktop monitor, but the system, the desktop system itself, it continues to function, it continues to work. That is fascinating. You saw it right there. We'll do it a couple more times. Going to battery mode. No flicker. It did not restart. How did it not restart that time? Going back to bypass. Switching to battery. Switching to bypass. Switching to battery. Switching to bypass. Switching to bypass. Battery. Back to bypass. Battery. Bypass. Battery. Bypass. So, that was a whole bunch of switching back and forth between battery and bypass with the inverter in appliance mode. Only twice did it happen where this desktop monitor would restart itself and it flashed the BenQ logo for just a moment. Alright, it only happened twice of all the numerous times that I've been doing the switching. As you saw, it only happened twice. So the next thing we can try now is to put one of the space heater loads and see if that will make any difference in appliance mode. Let's do the toaster oven, convection oven. I'll put that on the 1000 watt heat setting. So we'll turn that on now. We are currently in bypass mode, and we'll switch back to battery and see what happens. Switching to battery. Let's try it again. No problems. Switching to battery mode. Switching back to bypass. Switching to battery. Switching to bypass. Battery. It works. We don't see any system restarts. We don't see any flickers. The laptop stays on. No restarting on the desktop monitor. So Let's add more loads to it and see what happens. Okay, we have the 1500 watt space heater load on without the toaster oven, so it's just an additional 1500 watts. Battery, bypass, battery, bypass, battery. So no problem switching with a 1500 watt space heater load on the same circuit as well. Let's add toaster oven, convection oven on 1000 watt setting. So that's a total combined of 2500 watts. Let's switch back to bypass. No issues. Let's try it again. Battery, bypass, battery. Alright, so no issues. Laptop stays on, no restarting on the monitor, and the desktop system stays on. Let's go 3000 watts. So let's try a 1500 watt hot plate and the 1500 watt space heater. No toaster oven. Switching to battery mode. Switching to bypass. Switching to battery. Switching to bypass. Battery. No issues. So instead of the electric heaters, let's try a motor. Okay, the next load we will be trying is a shop vac. This is the same orange rigid shop vac that I used in a previous video with surge testing. I'm going to switch that on while we have bypass mode, and then turn off the AC input and see if we can successfully switch over to battery with the inverter in appliance mode. Okay, the shop vac is running, and we are going to switch to battery mode. Ready? Will this work? You saw it. The monitor restarted, but more importantly, the system is still running. I've put that benchmark test as a load on the system. It's still continuing the benchmark. As for the laptop, I don't think I saw any flicker on the laptop. It stayed on. The LED lights did flicker, and the duration of the flicker was a little bit longer than having just the computers by themselves. Switching back to bypass. Switching to battery. Switching to bypass. Switching to battery. I don't know how well you can hear that in the sound of the video, but switching to battery mode over from bypass, for a split second, you can actually hear the speed, the sound from the shop vac. It actually slows down a little bit. For a split second there, that's when power was reduced power. Not interrupted to where it will disconnect or shut off, but you can actually hear a slight reduction in the motor speed. We'll try it a few more times. Switching to bypass. Switching to battery. Bypass. Battery. No problems at all. For the last couple tries, I was actually flipping the AC input to the inverter on and off as fast as I can. So I was just, I was snapping the switch back and forth, and I did not see any restarting on the monitor, and the system continues to power the load, and it works like it should. Alright, so I have a additional 1500 watt space heater connected with the shop vac and the two computers. We are currently in bypass mode. Let's see if we can switch to battery mode. Inverter is in appliance mode. No way. No way. It just did it. It was able to switch over, and the two computers work just fine. Let's try it a few more times. Going back to bypass, going to battery, going to bypass, going to battery, back to bypass, battery, bypass, battery, bypass, battery, bypass, battery. Wow, so with a 1500 watt space heater, a shop vac, these two computers, with the inverter in appliance mode, these two computers are still able to function without any interruptions. I thought we might even see the monitor here restart, but it did not. It's interesting, it actually happened twice when we were using just the electric heater loads. Only the first 2 times. And afterward, it never happened again. So let's try a second motor. Okay, so I've got 2 motors running. One is the rigid shop vac, and the second one is the variable speed vacuum cleaner. Both of those motors with the 2 computers here and the inverter in appliance mode, switching back to battery from bypass. Let's see if it works. Again, the desktop monitor likes to restart itself. And the load, the benchmark that we're doing, the load test, it still continues to run. So it looks like the desktop computer is not really bothered by the switchover, even with the inverter in appliance mode. Remember, right now we're doing appliance mode testing, okay? Bypass, going back to battery. Bypass, battery, bypass, battery, bypass, battery, bypass, battery, bypass. No problems there, switching over between bypass and battery with those 2 motors. This monitor, it did restart the first time, and then afterwards, every other switchover after that, it never happened. So it's interesting why, it does that. Really, I have no idea, I have no clue. If you're curious about what's the power supply in the desktop computer that does the AC to DC switchover, this is the EVGA Supernova G5 650 watt power supply. If that makes any difference for the UPS, switchover testing that we're doing, I have no idea. But it is what I have, and it's just what I'm working with. Let's try the same thing with the inverter now in UPS mode. Switching to battery mode, bypass, battery mode, switching to bypass, switching to battery, switching to bypass, battery, to bypass. Okay, so I can say I've switched it back and forth over and over countless, so many times. Some of it was like a slower switchover with the AC input, and sometimes I would just flip it back and forth about once every second, and it doesn't make a difference. There wasn't any restarting or flickering with the monitor. The LED lights over here that are on the inverter output circuit also don't have any flicker in UPS mode. There actually is a tiny little flicker, but it's super quick. It's only in appliance mode where the flicker for the LED lights, the flicker duration would be a bit longer. So other than that, the UPS mode, it worked really well. I'm actually surprised even appliance mode that it can transfer the 2 loads for the computers without any problems. I actually find that a bit surprising as well.